Thanks, Antonio. So now moving to the last presentation by Mark Pananguma. So he has 10 plus years of experience in data architecture, software engineering, DevOps management, and agile methodologies. He is head of data engineering at SCM Lidl Digital Hub. He is an expert on building and managing highly scalable platforms and teams for advanced analytics. His current focus of work is design and build the center and big data platform for Nidin Group. And the presentation is how to build an agile and scalable data platform inside a big enterprise. So welcome, Mark.
Thank you. Sorry. It's working? Hi? Okay. Well, I will continue in English to not be disruptive. Okay, and I'm here to explain how to build a data platform, but inside a big enterprise. Okay, because it's in a specific way to build it. And it's different like in startups or digital companies, these kind of things, but have some points in common and others that are really, really different. Well, work? Yes. Who am I? My name is Mark Planaguma. I'm a senior data engineer. I start on a research related with data on different institutions like Telefónica R&D, Barcelona Digital, Berlin Big Data Center, and also the house, Eurecat. And I did the jump on the industry, first on Zurich Insurance and now on LIDL for the same purpose, build data platforms and build data engineering teams. Then, I'm here to explain how to build a data platform, how to build a data engineering team, but on a specific scope, on a big enterprise. Because big enterprises have their own scope, their own context, and other issues and problems. Well, what is the challenge to build a data platform and build a data engineering team in a big enterprise? Mainly, the two bigs are scale and be agile, related with size and velocity. This means that we need to do a platform that scales, because big enterprises normally have big data. And be agile, because if you have to build your own infrastructure, this means that you have to build your own technology, you have to be fast. Normally, the big enterprise, or in 90s and in 2000s, the big enterprise starts the outsourcing of IT departments, buying and different services from other companies to not be the owners of their own technology. Why? To be fast. But in case of data platforms, the data platforms are really close on the data, and the strategy is in the other side. It's build your own. I will explain why. But build your own data platform. But build your own technology, build your own platforms is something slow. Then you need to accelerate. And to accelerate this, we need to be agile. Then, goals. We need to build a platform as a team, and we have to scale and be agile. But in all directions. We need to build platforms that scales, platforms agile, but we need to build a team that scales and a team agile. We need to scale on technology, on data, but also in the size of the team and the specialization of the team. Then let's go for each couple of concepts. First of all, the how to achieve the scale of the platform. I will focus on three concepts. There are more. Analytics scope, because I'm talking about data platforms, not transactional or operational platforms. On a base a pattern of architecture, in this case is a layer architecture, and also some tips for this, scale by design, two designs that scales from the beginning. First of all, the scope. I'm talking about analytics scope. We have to split the analytics scope for the operational scope. This in enterprise is really hard because the enterprise is only focused on specific domains. In my case, in retail. But when I was in Zurich, was insurance, and banks is on finance. then all these companies are really focused on their own operational platforms, but not for the analytical ones. And sometimes have something that can be crossed, can be shared, but sometimes have paradigms or strategies that are really different. And when you are using the same platform for different strategies, you are not doing your best job. Then we have to build an analytics platform with a data ingestion and a data lake, or also a process, distributed process, also a computation and consumption services, and do a lot of analytics pipelines. But we have to do this thinking on a scale from the beginning. Okay, why? Because we have, in this case, for data platforms on enterprise, the main goal related with the last session is put all the data on the same place. Or if not is in the same place, put the data in some places that could be interoperable between them, okay? And this means that we need the raw data, all the data from all the sources that we have. We need to create a foundational data, or call it layer 1 on data lake, or we need to create a data market, a place where all the data in the company is there. Then non-normalized layers, the Hadoop wall and these kind of things, and also normalized layers, the data warehousing walls, or even some specific databases like Mongo, Redis, etc. Then this means that the scale-based design have to be focused on which these different layers have different strategies to scale. Then we need to use different technologies and different combination between them to scale in all the layers. Let's talk about the layer architecture. This is focused on the last slide. Layer architecture is a common pattern on big data wall, but at the end is use the different strategies for scale on different layers. First of all, we need to ingest data. We need to integrate data. We need to get the data from the different sources and get it. Put it on a raw layer. All the data is there. It's there in original format. On original format, we have the problem that is not interoperable between them. We need to change this format, or we need to do something to compare, to transform, to use one data with the other. This is the goal right now of data lakes. Probably in the future will be the goal of Snowflake and others. But right now is the goal of data lakes. But in top of these data lakes, we need to build a lot of things, a lot of data products, a lot of data proposals. Okay? This means this layer architecture is providing different kind of services on different layers. Going to the data lake, at the end is a place where all the data is there, is a place to do some research or data exploration. But this data is really far to be a product. Then we need to work a lot on non-normalized or tabular or Hadoop wall to cook, prepare, do something with this data. This is the place to do data pipelines, ML, etc. And at the end, when the data is ready, is the place to put this data on exploitation technologies, like data warehousing, BI tools, time series databases, etc. And then is the place to use more user-friendly softwares like tools from BI, etc. Let's go for another couple of concepts. Platform agile. First, about cloud. I will not explain what is cloud. My important part here is that we have to explode this concept, infrastructure as code. We need to be really agile. We are talking about platform agile. We need to be really agile on create the infrastructure. And the unique way right now to be really agile on this is create this infrastructure using different services on cloud, public cloud, private cloud, hybrid cloud, whatever you want. Use tools for infrastructure as code and create your own assets, your own infrastructure, building this combination. Do the architecture using models. Okay. To do a model-level architecture, in my case, or in my opinion, I think this is for two reasons. One is for technical reason, and another is for organizational reason. Why? For technical reason, because split a big problem in pieces is some cases a good idea to get focus, but also is a good idea to have teams really specialized on this topic. Then this is, again, a kind of layer architecture, but in a specific picture. We have the ingestion, we have the process of data, we have the consumption, and we have a lot of cross services, like data catalogs, data lineage, security and access control, monitoring and logging, different services that are cross in all the pipeline, in all the stack, and have to be built in the same time that you are building a data platform. If you have a data platform without user access control, then this platform will work, but will be not ready for production. And also, to have a platform agile, you need to have full control of the stack. What means? From the beginning, from the ingestion to the passing through the data lake, creating non-normalized models and arriving to products, we need to be able to decide which technologies you want on each step. This is an example of how to do it with different technologies, the different layers, and it's a matter to use or improve and do some evolution on your platforms in different layers and different components, and be really agile on change these components for other solutions. Because right now we have a data lake. In our case, LIDL is using Azure Cloud and Google Cloud, and is using services from both clouds, but probably in the future we'll use Snowflake, I don't know. The idea is to be agile to replace this tool. You have to build your architecture to be able to change. Then we will jump to the team topic and different aspects to achieve a team that scales. First of all, this topic could be really huge. I will try to be fast about the definition of data engineering role. Right now, data engineering is a hype. It's something that 2 years ago or 3 years ago was something not famous. The hype 2 years ago probably was data science. But when the data science people start to work, the problem is always the same. Where is my data? Why the data is really poor, or why the quality of this data is really bad? Or why this data is on this silo and this data is in this other silo and I'm not able to cross it? Because the environment is not ready. Then for me, the data engineering teams are the engineering teams that tries to create this environment to build data products on top. You can find a lot of definitions from references. In my case, I'm trying to define the scope of the data engineers crossing different skills and competences, like a developer on distributed systems, architect on system and data, and some analytics capabilities. But at the end, we need a team of engineers that are able to build the environments to cross and work with data. Another point that for me is probably the key on build data engineering team is use a matrix organization. The most famous matrix organization is the Spotify model, but it's not the unique one, even it's not the biggest one. and is an organization that divides on a vertical and horizontal groups of people. The vertical ones are called the squads, and the horizontal ones are called chapters. The chapters are groups of people with the same skill or competences. In my case, I'm the chapter lead of data engineering on LIDL. This means that in my team, we have a lot of data engineers, not all of them with the same skills, different skills on this topic, but a lot of same different engineers, but all of them are not working together on a department. These people is working on different projects, and each project have a squad. Squad is a group of people with different skills coming from different chapters with the specific skills that are needed to build a product, a specific product. Then this means that on horizontal level, we are managing the issues or the topics related with the skills, with the knowledge. And on the vertical level, we are managing the topics and the issues related with a specific product, with a goal, a specific goal of a product. Another point, to scale, hiring is the key. To scale on a team, we need more people. But we need to, when we have a big demand on growing, we need also be really smart on hiring. It's not a matter to get a lot of people and then don't be able to manage these people because these people is not matching on your culture, even on your goals. Then we need a specialized process, a really deep technical specialized process for these teams. We need to focus on skills and even in culture. And also, the enthusiasm for the product is really, really, really important, even more than the skills. The last couple is how to achieve a team agile. First of all, the agile methodologies. But I will not explain Scrum or Kanban or others. I'm focused on how to achieve, using agile methodologies, how to achieve a high-performing teams. This means, or for me, in my opinion, we have to cross all the methodologies, all the protocols defined on agile methodologies and others with these three topics. Provide autonomy to the teams, find the mastery, and even give a really clear purpose to the teams. If these three topics are not really clear, with only agile methodologies, the team is working, but never is arriving to be a high-performing team. Last one on this combination, team agile, is the processes. This is the process that we are working right now on LIDL. It's not the unique one, but it's a process how to work in front of data goals. What means this process? Well, in the beginning, we have a data goal. We need to achieve something using data. For this could be a squad because we have different skills on the team. To achieve this goal, someone, the domain expert or who has the idea, needs to describe the idea to the team who have to develop this pipeline. Then the PO or the business analyst is who works with the data engineers to transform this idea on a test. This test is transformed by data engineer itself on a code, on a pipeline. This pipeline is tested for a QA on specific on data, if it's working or not, and finally it's released on prod. When this pipeline is released on prod, the responsible, the owners on the beginning, the PO and the business analyst, is who checks if the data at the end is the data that they wish or not. This is a specific process, could be another, but to get a team agile are needed this kind of process, not only inside each step, even the relation with steps. And finally, the data culture. Okay, probably the software culture is something really extended, but the data engineering culture is something probably really new. Not on a full digital companies or startups, but yes, on big enterprises. Well, a lot of concepts: data integration, data preparation, data exploitation, data analytics, data productivation, data exploitation, data quality, data governance, at the end, data value. We have a pyramid with the data platforms on the bottom line. We have data science on top, reporting and data products on top, and at the end, insights. We need to build this with teams, but also with culture. And at the end, the recipe of LIDL to achieve this. LIDL Plus starts to being only a loyalty product for LIDL, but at the end, achieve to be at the end, all the loyalty programs are thought to explode the data, to extract value from the data. Data from users and data from products. Also a key on our case is that we start being a spin-off, completely isolated from the headquarters, with freedom on decide the technology, decide the infrastructure, decide the organization, decide wherever. Now we are part of LIDL as a digital hub here in Barcelona, but we are maintaining our independence. Not on organization, because we are now, but we have our own independence on technical aspects and on methodologies and organizational aspects. This is the key to be agile, and this is a success case inside LIDL for this freedom. Okay? And at the end, also for this freedom, for this case, we achieve to build our own data team and our own data platform. Finally, you have to know that we are growing and we are hiring. You have my contact here, and if you are interested to work in my team, please touch me.
We have time for one question.
¿Qué tal? ¿Nos podrías dar una idea de la cantidad de squads que estáis trabajando y el tamaño aproximado de esos squads? Y si es que se relacionan entre sí, ¿cómo funciona esta gran organización en modo agile?
Sí. Te diré, bueno, por tamaño, ahora en la empresa creo que ya estamos cerca de los 21 o 22 squads. Y también te hablaré de los chapters, ¿vale? Tenemos chapters y tenemos tribus también, que son agrupaciones de chapters. Tenemos la tribu de data, y data son los chapters de data engineering, data science, BI, business analytics, y parte de la de DevOps, ¿vale? Que es compartida. Tienen sus grupos de especialistas, de data science, de gente de BI. Yo tengo mi grupo de data engineering y trabajan en distintos squads. Los data engineers trabajan en dos tipologías de squads. Los que hacen plataforma o infraestructura y los que hacen producto. Los que hacen plataforma, de hecho son tres squads distintos, el de infraestructura, el de ingestión y el de lake. Al final lo que hacen es un servicio interno para preparar, y tienen unos OKRs muy definidos, para que cada vez el trabajo de los data engineers en los productos sea más ágil y más rápido. los data engineers que trabajan en producto tienen un foco, hacen un recomendador, una forecasting tool, un reporte de programa, un reporte de controlling, un reporte de finanzas, una exportación de datos, etcétera, etcétera. Tienen un foco muy concreto y trabajan con data science, con BIs, con backends, con frontends, depende de lo que hagan, trabajan con varias gente, trabajan encima de la plataforma y su foco es el caso de uso. O, en el caso de la parte más data science, no tienen caso de uso, sino tienen una teoría a probar o no probar, ¿vale? Pero esa es la idea. Lo que me gusta a mí, intento, es que la migración entre producto y plataforma sea algo que pase. Porque quien construye una plataforma es su mejor prescriptor. No se tiene que leer el manual porque sabe cómo funciona. Y quien usa una plataforma le encuentra las costuras. Sabe qué le falla, qué necesita. Si esa relación es simplemente una recogida de requerimientos o un buzón de sugerencias, esa comunicación se pierde, es muy pobre. Lo mejor es que esa comunicación sea directamente que la persona se mueva y pase de hacer producto a hacer plataforma. Por eso también ayudan las metodologías ágiles que hacen que los sprints acaben y que haya releases, y cuando acaba una release te libera de poder salir de este proyecto. No pasa como los waterfall, que nunca estás liberado del proyecto porque nunca acabas. Los squads se sincronizan por dos partes. Una, que es a nivel de producto, los POs están sincronizados. Los productos tienen que tener una dinámica común, y luego tienen que utilizar los chapters. Los chapters son los que hacen esa sincronización a nivel de cada capacidad, de cada skill. Por tanto, hay muchos niveles de sincronización. En nuestro caso, no tenemos squads que compitan en un mismo producto, pero hay empresas que sí lo tienen. Eso quiere decir que el modelo squad te permite, o tienes que hacerlo, porque cada squad es independiente. Puede estar haciendo exactamente lo mismo que el de al lado sin enterarse. Aquí nosotros intentamos que no pase, pero hay otras empresas que promueven que pase, porque tienen un tamaño tan grande que saben que si varios equipos hacen lo mismo tendrán la mejor solución. Aunque les cueste mucho dinero, saben que necesitan la mejor solución, por tanto, la competencia interna genera esa mejor solución. Por tanto, nosotros no lo usamos, pero en otras compañías sí que usan esta estrategia. This one more? No?
We have time?
Okay.
We don't have time, sorry. So you can ask questions, because it's 6 and we have to start another workshop. So you can just ask the question offline. So let's thank Mark once again. Thanks, Mark. So with this, we'll be closing this session. And just an announcement, there is another session starting. I know everybody's tired, and the printed version says it's going to be 1.5 hours, but we have decided to make it shorter. So still, if somebody is interested in machine learning in production, come to the other workshop. And that's all. Have a nice evening. Thank you for coming.